Welcome to The Explainer. Today we're diving into a fundamental economic idea, one that kind of shapes countless decisions, but you might not even know it's there. It's called the principle of increasing cost, and once you get it, you'll start seeing the world a little differently.
So let's start with a really simple question that gets right to the heart of what economics is all about. When you choose one thing, what are you actually giving up? And I'm not just talking about money here. I mean the opportunities you just have to let go.
You know, economists have a special term for this. It's called opportunity cost. And it's really the value of the path you didn't take. It's the ghost of what could have been. Every single choice we make has one.
Okay, so every choice has a cost, a trade-off. But what happens when you keep making that same choice again and again? Well, as we're about to see, that cost doesn't just stay flat, it actually starts to grow in some pretty surprising ways.
Think about it. Every single time a company or even a whole country decides to produce more of one thing, they're paying a price. But that price isn't really measured in dollars, it's measured in all the other stuff they can't make anymore. And here's the kicker. That cost is almost never the same from one unit to the next.
And this leads us directly to the core idea for today's explainer, a fundamental law that explains why those trade-offs get more and more painful.
And here it is, the law of increasing cost. It sounds a little formal, but the idea is super simple. The more you produce of one thing, the opportunity cost, what you have to give up, gets bigger and bigger for each new unit. The first one might be a really easy trade-off, but that 1,000th one, oof, that's going to be incredibly expensive in terms of what you're sacrificing.
So why does this happen? Well, it's because resources, people, land, machines, they're all specialized. They're not just interchangeable cogs in a machine. You can't just take a brilliant farmer who knows the land inside and out, stick them in a factory, and expect them to be a world-class car mechanic on day one. It just doesn't work that way. You lose efficiency.
Now, what's really cool is how economists draw this idea. They use a graph called the Production Possibilities Frontier, or PPF, and you'll always notice this distinct shape. It bows outward. That curve isn't just for looks, it's literally a picture of increasing cost. See? To get your first few cars, you only give up a tiny bit of food. But to get those last few cars way over on the right, you have to sacrifice a massive amount of food production.
All right, let's move on and see how this plays out with some concrete, real-world examples.
And this slide just illustrates the difference perfectly. On the left, you've got those classic increasing cost situations. Taking fertile farmland and trying to build cars on it, that's going to have a huge opportunity cost in lost food. But now look at the right. A factory that makes notebooks can switch from making blue ones to red ones with basically zero extra cost. Why? Because the paper, the ink, the machines, they're perfectly adaptable for that tiny change. The trade-off is constant.
So, that bowed-out shape we keep seeing on the graph, it's not just a sketch. It actually has a very precise mathematical meaning, and honestly, the implications are huge.
That PPF curve, the one that bows out, is what mathematicians call a concave function. The best way to think about it is as the curve of diminishing returns. You know the feeling, right? The first person you hire gives you a massive boost in productivity. The 10th person helps, but a little less. The 100th person, they might barely move the needle. You're getting less and less bang for your buck. That is a concave function in action. Now, the exact opposite of that is a convex function, which curves up. And this shape perfectly represents the cost of production. So while your output for each new worker is diminishing, that's the concave part, the cost to produce just one more item is increasing, and that's the convex part. They are literally two sides of the very same coin.
Okay, but this difference between concave and convex, it isn't just some abstract thing for academics. It is absolutely critical for solving enormous, real-world economic problems.
So why should a CEO or a government policymaker care about these shapes? Because these curves are the key to finding the best possible outcome. They mathematically guarantee that for a really complex problem, there isn't just a good solution. There is one single best solution out there.
And here's basically how it works. If your goal is to maximize something, let's say profit, you model it with a concave function. And because of that unique shape, when you find a peak, you know with mathematical certainty that it is the only peak. It's the global maximum. It's like you found the true summit of Mount Everest, not just a little foothill that looks like the top from where you're standing.
And this right here is the magic. It means that decision makers can be totally certain that they have found the very best strategy possible, whether that's minimizing their costs or maximizing their output. They don't have to worry about getting stuck in a good enough solution that isn't really the best one.
So the next time you hear about some huge business strategy or a new economic policy, just ask yourself, are they winging it or have they actually found the peak of the curve? Thanks for joining me on The Explainer.